Okay, we're live. So what we're doing here, these are called piecewise functions. They're actually very simple. Okay, so I think you guys will find them to be pretty easy to deal with, fairly intuitive. So first, a little preface here, like when you're doing like computer programming, computer science stuff, a lot of times you'll have a situation where you have like an input. Let's say the input is X. And what you do, your function does a thing where you say, you check, you say, if X is, let's say, bigger than 100, then the output, I don't know, let's say we double our input if X is bigger than 100. And then you say, if X is not bigger than 100, then I don't know, let's say you triple it. You get that basic idea? So for example, let's say you plugged in the number 20. Say X is 20. Is 20 bigger than 100? No. Is 20 less than 100? So you plug it in, what would the answer be? 60. And then also, let's say you plugged in 150. Okay, same thing. Is 150 greater than 100? Yes. So I double it and get 300. So that's the basic idea behind a piecewise function is depending on the value of your input, X, you follow one or another rule. Or there could be three possible conditions. You could say, here's a condition for negative numbers. Here's a condition for numbers between 0 and 5, and then here's a condition for numbers from 5 to infinity. So you can have any number of conditions in your piecewise function. So the first one on your problem set is like this. What is X plus?
X is less than 0, X minus 2, and X is greater than or equal to 0.
Okay. So you can, let's do this by first looking at the F of blah problems. So I misplaced my own paper here. That's okay. What's the first one that we're being asked? F of -2. So what you do, okay, so the most fundamental level of these, all you do is you go, okay, F of -2, okay. These are the conditions here. So is my X value less than 0 or is it greater than or equal to 0? It's less than 0, so I follow this rule. So what's the value? 1. Great. How about F of -1? Same process. Is -1 less than 0? Yes. I get 2. Make sense so far? And I asked you one out here, how about F of -0.001? Yes, that number is just barely, it is less than 0 though, so it'll get plugged in there. What's the value? 2.999. By the way, that number is awfully close to 3. So what do you guys think I'm attempting to get you to think about here?
That's where the...
Sort of, yeah. Limits. I'm trying to get you guys to think about limits. So this function, what you're going to find, there's going to be a hole there, totally, is when you have a piecewise function, it's often interesting to look at the limit as you approach from the left, and the limit as you approach from the right for this value here, the value where we're changing rules. Okay, so then what is F of 0? -2. So this often throws off, usually throws off younger students when they first see this, like a question of true or false, 0 is greater than or equal to 0. Kind of looks like a face. But this is a true statement, okay? 0 is greater than or equal to 0 because it's equal to itself. So we follow this rule. 0 minus 2 is -2. All right. Then you're asked about f of 0.001. That number is greater than 0, so it gets plugged in here. Negative 1.999, which again is awfully close to what?
2.
Negative 2. So what these two are telling us, and we're going to see this graphically, is that, and this is coming up pretty soon here, limits. The limit as we approach 0 from the right-hand side is negative 2, and the limit as we approach 0 from the left-hand side is 3. We're going to see that bear out in the graph. Okay, so then f of 1, negative 1, f of 2 would be 0. Okay. Now, can I put all these dots on my paper and kind of graph it that way? Yes. I'd really advise against that being like your primary method, just because I used to think that should be a fine way of doing it, but over the years I've seen a lot of students just they somehow miss something really fundamental about how these graphs work when they do it that way. So what I'd really suggest to understand them is something like this. Look at this guy. Okay, what does that look like by himself? So imagine nothing else was here. You just saw y equals x plus 3. What does that look like? Well, looks like that, right? Where this is the number 3. And then how about if I graph this by itself? Y equals x minus 2. We're okay with that, right? Hopefully. So which part of this graph is going to go in my final graph if we're grabbing the negative x values? Is it the left half of the graph or the right half of the graph? It's the left half. So we're going to grab this left half here. So notice this zone that I'm taking is the graph for all the x values less than 0. And then I'm going to grab the right half of this graph, which is all the x values that are greater than or equal to 0. And so when I make my graph, it's going to look like this. I'm going to leave something out. Oh. So I did this. I'll just do this way. Okay. There's one little mistake on there. Beware. Yes, what's the mistake?
It's not a whole lot -2, but it's greater than.
Very good. So this dot, this point is a point on the graph because of this. Well, what do you think of this, or the fact that when x actually is 0, the y value of the function is indeed -2. Okay. So do you guys see how the left limit is 3 and the right limit is -2? If it wasn't clear before, now we can see the graph. Hopefully it's clear. Okay, so let's do one more together. Hey. I don't know where any of my stuff is. I'll save the second half of the page for you guys. Let's go to the next page and find one that's a little bit more challenging. Maybe let's do 4. 4 will be interesting.
Okay.
Nice collective groan. Good stuff. What's wrong with number 4?
Fraction.
Yes, you do. I think you do. In my opinion, you love them. No, it's my opinion. Sorry. What is it? It's 2.
Yeah, take it.
Thank you. All right, this one's a bit. more challenging. Ignore everything else except for this. If we were to graph just a simple y equals 2 over x plus 1, what's an interesting feature that this graph has?
It's expanded.
2 would, yeah, stretch it vertically, but what is the bottom telling us? A vertical asymptote at -1. Okay. So let's just draw a little. Let's do some of the opposite orders. This time I'm going to sketch the graphs, get all the graphs, and then we'll look back and get all the f of 2, f of 1, whatever. Okay. So this graph, vertical asymptote would be at -1. How about the y-intercept? 2, very good. 1, 2, tie my shoe. Okay. And then what's the end behavior? What does this thing approach as x gets really big? 0. So that tells us the graph looks something like this. Or we can think of it as a stretched, shifted 1 over x function. That's another way you can kind of think about this one. But in any case, this is what it looks like. And I'm going to also identify this point right here. When x is 1, what's the y value when x is 1? 1. So why do you think I care about that point? Just because it happens to have integer coordinates? Very good. Very because
That's where it's going to be.
So the answer is I'm really interested in what happens when x is 1, because that's the x value where the function changes from this rule to this rule. So that's going to give me valuable information about how the function behaves. So by the way, what half of this graph am I going to end up working with in my final answer? To the left of 1 or to the right of 1? To the left. So I'm going to grab all of this. All of this is going to be on my graph. Do we have questions? Okay. And again, I'm only grabbing this part because my function f only follows this rule when my x values are to the left of 1 or at 1. Okay, then this is a bit simpler. Y equals x minus 3. Again, I'm really interested in what happens when x is 1. If I drew the whole thing, it would be like this. 1, 2, 3. Let me do a better job here. 1, 2, 3. So what point do I care about? 1, -2. Okay, so then what part of this graph am I going to grab? To the right of 1. Okay. Overall answer. 1, 2, 3. It's kind of all the dash marks I really need, honestly. Maybe actually this would help. I don't need a ton. So let's draw that in. So I'm going to draw this part. There's my vertical asymptote. There's my y-intercept. I'm just being nice and careful here, just making sure my drawing is somewhat legible. Is everyone okay with what I just did there? Okay. And now let's get this guy involved. There we go. There's the function. Kind of weird looking, right? So there's my 2 over x plus 1 part. There's my x minus 1 part. And then notice the jump happens at 1, which is what the function told me to do. And then the rest, maybe we can just go over that verbally. Like, it's asking for What's f of negative 2? What do I do with the negative 2 if I'm asked f of negative 2? I plug it into here, and I get negative 2. How about f of negative 1? Well, that's undefined, isn't it?
Yeah.
Did I ask you for f of negative 1?
No, you're right.
God, so savage. Undefined, f of negative 1 is undefined. You'll be dividing by 0. What's f of 0? 2. And you guys, let's make sure you understand here. Do you see how all of these are showing up on the graph? There's a connection there. If you're not seeing the connection, you're missing something big time. So make sure you understand that connection. How about f of, does it ask f of 1?
Yeah.
F of 1 would be 1. F of, does it ask f of 2?
Negative 1.
Oh, okay. F of 3, 0. F of 4, 1. So just double check your own brain. Do you understand how all of these statements relate to the graph and how they relate to the original statement of the function, how they relate to this equation? And if not, we could discuss it. We could try to figure out what part is not making sense for it. Okay. That's it. That's all there relates to piecewise functions. We'll have some work time in class tomorrow so you can practice.
Thank you.